Hi, this is David. Welcome to a video review. We are located in Part 1, Topic 2, Quantitative Analysis, and the textbook is Stock and Watson, Introduction to Econometrics. You might also have or be using the brief edition, and it doesn't matter what we care about. The basic set of concepts that relate to regression are the same across the editions. Stock and Watson has been assigned for several years, so we have a good sense of what the FRM expects. And in fact, econometrics goes back over a decade in the FRM, so it's well seasoned. But we do start here in Chapter 4 of Stock and Watson, which is called Linear Regression with One Regressor. Stock and Watson have their own set of terms that they prefer, as is often the case in finance. We have different terminologies that sometimes mean the same thing. So some of us, instead of regressor, are used to calling this an independent variable. Okay, so that independent is synonymous with regressor. So this is linear regression with one independent variable. And personally, I prefer to call this, what we're talking about here, univariate regression, as opposed to multivariate regression, where we have multiple independent variables. So single independent or one regressor is what we're talking about here in Chapter 4. And we'll see that the set of learning objectives includes explain how regression analysis and econometrics measures the relationship between dependent and independent variables. And then we have some terminologies and their relationships, including population as opposed to sample, otherwise similar, and then key properties of the linear regression. Now, long set of learning objectives, although, as I've said before, there are some, these could be streamlined more, GARP could. I think there's some redundancies in here because we're primarily referring here to ordinary least squared regression. That's the common regression that most of us are familiar with, and how that's estimated and what it means to generate OLS estimators. So we'll look at that in the slides to come. And then this second to last or penultimate learning objective is important because we want to look at the sum of squares concepts, explain sum of squares, residual sum of squares, and the R squared and the standard error of the regression. So that's so there's some redundancy here, I think, could be streamlined, but this learning objective is important. And then, as usual, we do have some examples, and all of which are in the learning spreadsheets, in most cases dynamically. So we start with the first learning objective: explain how regression analysis and econometrics measures the relationship between dependent and independent variables. So you can see there are already, GARP is preserving what I think is maybe the more familiar terms in the regression equation: dependent and independent, right? We regress a dependent against an independent variable, although Stock and Watson tend to call this the regressor, and they call the dependent the regressand. But the linear regression may have one or more of the following objectives: to estimate the conditional mean of the dependent variable, to test a hypothesis about the nature of dependence, to predict or forecast dependence or dependency, and one or more of the above. And just briefly, I'll just make a note here about dependence versus linear regression that we're looking at, because this is thematic, especially in Part 1, Topic 2. Dependence is the general idea. If we have a linear relationship that would be manifest in a linear regression, and therefore, for example, a linear relationship would imply a correlation coefficient that's greater than 0 or not, I should say not equal to 0, right? If we have a linear relationship, we'd have a correlation coefficient of not equal to 0, or could say rho not equal to 0. Let's say that's a linear relationship. Well, that implies dependency between the variables, but we know that the converse is not true, because a linear relationship is a very special case of a relationship. And that's the whole topic of this chapter and this video review, for that matter. We're doing a we're looking at a linear regression and therefore a linear relationship. If there is a linear relationship, or we're testing the hypothesis and we find it to be true, such that the correlation coefficient is, let's say, high or significantly high, then we've found evidence for a dependency. But because that's such a special case, the converse is not true. If variables are dependent, we wouldn't necessarily, it does not necessarily follow that we're going to get a linear relationship. After all, the dependency could be a non-linear relationship. So that's just a reminder about the key difference between dependency as the very general relationship and versus the more specific case of a dependence, which is a linear relationship that would be captured or manifest in a linear regression and some of its associated metrics, like a Pearson's correlation coefficient.